Okay, so now we're talking about secretion, which is movement in the opposite direction as reabsorption. So reabsorption, we move things from the tubular lumen across the PCT cells into the interstitium, and then it got picked up by the peritubular capillaries, things like sodium and glucose and water. Now we're going to focus on three things that we're going to move from the blood across the renal tubule and into the tubular lumen. Anything that's in the tubular lumen will be lost in the urine. The thing about the process of secretion is almost invariably anything that is secreted into the renal tubule requires ATP. So all of these processes involve active transport. So I'll start with hydrogen ions. And hydrogen ions, build up from metabolism. So we're highly acid-creating creatures. So acids, hydrogen ions, get moved across the renal tubule cells and into the tubular lumen by active transport. And actually there is something called an antiport. An antiport is a protein that moves two things in opposite directions. And so sodium often gets traded, so to speak, for hydrogen. So we will pull in sodium through this antiport while hydrogen gets moved in the opposite direction into the tubular lumen. And it requires an expenditure of ATP. The second item we want to focus on for secretion is potassium ions. And the major way that potassium is lost from the body is through urination, and it's under the influence of the hormone aldosterone. So when aldosterone is secreted by the adrenal cortex, it targets the cells of the DCT, and it stimulates the activation of the sodium-potassium ATPase pump, where sodium gets reabsorbed and potassium gets secreted into the tubular lumen. And of course, we know that that requires an expenditure of ATP. As sodium gets absorbed into the bloodstream, there's this obligatory osmosis of water. Water moves into the blood as well. So the effect of aldosterone is not only to increase the amount of sodium reabsorbed and potassium secreted, but also to increase the amount of water reabsorbed indirectly. Finally, the kidney tubules can take drugs that you might be taking, like antibiotics or other types of medications, and to reduce toxicity or prevent toxicity, the kidney can actively move those drugs into the tubular lumen. So we have the three things that we focused on: hydrogen ions, potassium ions, and drugs. May all be secreted into the tubular lumen to be lost in the urine. Some of them are driven by antiports, where two things are moving in opposite directions using ATP. Some of them are driven by hormones like aldosterone, and some of them are just actively transported, such as drugs.